Have you ever felt like it's easier to land a job on another planet than on an offshore oil rig? Well, you are definitely not alone. Today, we're going to dive deep into the incredibly high-stakes world of subsea engineering to figure out why this field is one of the toughest and, honestly, one of the most fascinating to break into. You know, this quote from Reddit just hits the nail on the head. It's a feeling you see all over engineering forums. You've got the skills, you've done the work, but that door to the offshore world just seems welded shut. So, what is really going on? Is it just a crazy job market? Or is there something fundamentally different about working 2 miles beneath the waves? Well, to find the answer, we have to go way, way down, deep beneath the surface, into what is literally one of the most hostile and challenging engineering environments on the entire planet. Okay, so why are these companies so hesitant to hire experienced onshore engineers? The answer is pretty simple, but it's also profound. It's not just about changing your work address. Subsea engineering is a whole different ballgame. I mean, the complexity here is just on another level. Think about it. You're designing this incredibly intricate system of robotics, hydraulics, and electronics that has to work perfectly for decades, thousands of feet underwater, with basically zero chance for a quick fix. And get this, even a simple routine job can cost millions of dollars, all while you're trying to follow a mountain of safety regulations. So you see, in a world this high stakes, companies just can't afford to risk on-the-job training. They need people who already speak the unique language of the deep. So let's actually go there. Let's explore that workplace and see exactly why this expertise is so critical. All right, so down here, the laws of physics are not your friend. They are a relentless, hostile force, and they're constantly trying to crush, freeze, and corrode every single thing you built. The numbers themselves are just staggering. First up, let's talk about depth. We're looking at wells drilled in over 11,000 feet of water. That's just insane. To give you some perspective, that's like stacking 8 Empire State Buildings one on top of the other, and then you finally get to the seafloor to start drilling. And at those depths, you get absolutely bone-crushing pressure. We're talking 3,000 pounds per square inch pressing on every single surface. The tiniest flaw in a piece of metal isn't just a weakness. It's an invitation for a catastrophic implosion. Game over. Okay, so if the pressure doesn't get you the cold will, the temperatures down there are hovering right around freezing. This creates a huge engineering nightmare called flow assurance, which is basically a constant battle to keep the oil and gas flowing and stop it from turning into some like frozen asphalt inside the pipes. And all of this hostile environment, it forces a completely different way of thinking. You can't just send a mechanic down with a wrench, right? So every single component has to be designed from the ground up for absolute bulletproof reliability for the entire life of the field. And that philosophy leads us to one of the most critical safety devices ever invented. When you're drilling into a reservoir that's been under unimaginable pressure for millions of years, you need an ultimate failsafe. And that failsafe is this absolute monster of engineering called the Blowout Preventer, or BOP for short. The BOP is this multi-story stack of hardened steel valves and hydraulic rams. It's designed to do one thing in an emergency: slam shut with so much force that it can literally shear right through the thick steel drill pipe. It is the absolute last line of defense against an environmental catastrophe. And because failure is just not an option, this thing has backups for its backups. You can trigger it from the rig with an emergency disconnect. You can send it a kind of secret handshake through the water using acoustic signals. You can even have a robot swim down and physically force it shut. And if all of that somehow fails, a dead man switch is designed to automatically seal the well if the rig ever loses connection. It's incredible. So that brings up a really big question, right? If you're an engineer and you can't see or touch the equipment you're responsible for, how in the world do you actually do your job? Well, the answer means you have to totally flip the entire philosophy of maintenance on its head. Yeah, this comparison really says it all. On land, a lot of maintenance is reactive. You fix it when it breaks. Subsea, that's a recipe for disaster. So the entire approach is proactive. Engineers are constantly monitoring this fire hose of data from thousands of sensors, looking for tiny little anomalies, a slight change in pressure, a subtle new vibration, and they fix problems before they can turn into a multi-million-dollar shutdown. And the primary tool for this delicate remote surgery is the remotely operated vehicle, or ROV. These advanced underwater robots are literally the engineer's eyes, ears, and hands on the seafloor. They let them perform incredibly complex tasks. We're talking everything from turning a single valve to replacing a control module the size of a small car, all while sitting safely in a control room on the surface. And this is where the tech gets really, really cool. An engineer on a rig can use their explosion-proof tablet to stream a live video feed from an ROV directly to a design expert who might be thousands of miles away. They can get real-time advice, annotated right on their screen, and solve a complex problem in a fraction of the time it used to take. Now, you might be thinking it's all high-tech robots and computer screens, but subsea engineers still rely on a specific set of physical tools. And just like the environment they work in, these tools have to be unbelievably tough, totally reliable, and in many cases, intrinsically safe. So, what are they carrying around every day? Well, you'll find some tried and true essentials. A Leatherman for those quick, unexpected fixes, an intrinsically safe flashlight, which means it's certified not to create a spark in a gassy atmosphere, a pair of Kinepix pliers because, well, they're simply the best, and custom-molded hearing protection to save your hearing from the constant roar of machinery. And their digital toolkit is just as specialized. No, these are not your off-the-shelf electronics. We're talking about 8Tech certified rugged tablets and smartphones that are built like absolute tanks and guaranteed not to ignite anything, alongside diagnostic tools like infrared thermometers and multimeters that let them see problems the naked eye would completely miss. So when you put it all together, the extreme environment, the remotely operated technology, that proactive mindset, the specialized tools, you really start to get the bigger picture. The barrier for an onshore engineer isn't about location. It's about a deep, fundamental specialization in a world that operates by a completely different set of rules. And that leaves us with a fascinating question for the future. As automation, AI-driven diagnostics, and autonomous robots become more and more common, what happens to the job of the human subsea engineer? Will it become more simple, or will it evolve into something even more complex, requiring a level of systems thinking that we can only begin to imagine today?